Hi everyone, this is Dr. Swaminathan S.M., Associate Professor EC Department, SNS College of Technology. Now, I am going to discuss about the plot called Nyquist plot. So, under the Unit 3, Frequency Response Analysis, the previous topics we discussed already, Bode plot using similar graph sheet, and second, polar plot using polar graph sheet, and the Nyquist plot that is used same thing. We just reverse the polar plot, that is called the Nyquist plot. Okay, so please remember this. Using this polar plot we will discuss in the Nyquist plot. And first, the introduction about the Nyquist diagram, that is Nyquist plot, which is used to define the two quantitative measures of how the stable system is. So we need to find the stability of the system using this Nyquist plot. So that is called, using these two different margins called gain margin and phase margin. So based on this gain margin and phase margin only, we can decide whether the system is stable or not. So the systems with greater gain margin and phase margin can withstand greater changes in the system parameters, that is before becoming unstable. So based on the system gain margin, that is phase margin must be greater. So it will be withstand the greater changes in the system parameters. There are so many parameters before becoming the unstable. And next, the gain margin, that is gain margin is the change in the open loop gain, which is expressed in the decibels, which is required at 180-degree phase shift to make the closed loop system unstable. Next, the phase margin pi m. The phase margin is change in open loops phase shift required at unity gain to make the closed loop system unstable. So first thing, we just make the comparison. Gain margin is nothing but change in the open loop in 180-degree phase shift to the closed loop unstable. So first one open loop, and the second, that is 180-degree phase shift to make the closed loop unstable. So please listen, first open loop and 180-degree phase shift and the closed loop unstable, and same thing for phase margin. So open loop phase shift, which is required to unity gain to make the closed loop unstable. So the three comparison between these two, phase margin and gain margin. And the introduction about the Nyquist plot. So here the x-axis is the real axis, y-axis is the imaginary axis, and left-hand side GH plane, and it makes the unity circle for 1. So left-hand side -1 and right-hand side 1. You just draw the unity circle. And first thing, this gain difference, that is gain margin, that is 20 log A. So the margin of the gain margin, modulus of GH, that is nothing but 1 by A. So A, from this equation you can get the A is equal to 1 by GH, modulus of GH, that is called the gain margin. And the arc of GH, that is plus or minus 180-degree. So you can get the Nyquist diagram. So left hand side, look at this -1 by A, because it is draw in the -1 by A, that is reversed to this side. And again the gain difference between the before the instability, that is between the difference between -1 by A and -1. And again you just draw the angle, that is 1 between the draw the angle, you just called the infinite, that is alpha. And gain margin, that is 20 log A in dB. So you can get the phase differences before instability, that is called the phase margin pi m is equal to alpha. So for the stability, the phase margin must be +1. As the phase margin approaches the 0 degrees, the system becomes more oscillatory function. So this is the simple introduction about the gain margin in dB and the another phase margin. So the two important concepts we need to know, gain margin and the phase margin from this diagram. And next, For the Nyquist plot, the response analysis, that is the frequency response analysis, we are having the link which is available in this slide. And here, for stability, you must know the pH must be positive. So phase margin that must be positive. Then only the system will be the stable condition, the stability conditions. As the PM approaches the 0 degree, that is, if it is not any values, so just consider as the 0 degree, the system becomes more oscillatory function. So this is the important concept for stability for the Nyquist plot conditions. Thank you.